Question 4. Okay, explain why an object moving in a circular path requires a resultant force to act on it even when it's traveling at a constant speed. So, any explain question, always check how many marks it's worth. This is worth 2 marks, so make 2 points. The direction is changing. The direction, and hence velocity is changing. Hence accelerating and F equals ma. I think that's probably more than I need for my 2 marks. So here we've got an example. A metal sphere is whirled in a horizontal circle on the end of a thin steel rod. So this is horizontal, this circle, so we don't have to worry about weight or anything like that. This is the view from above. The breaking stress of the steel under tension is 450 megapascal, and the rod's diameter is 0.12 millimeters. So a little bit of materials to be had here. Show that the greatest force that the rod can exert is 500 newtons. So this is a breaking stress. Remember that stress is equal to force over area. So therefore the force is equal to area times stress, which in this case is equal to, we've got to be careful here, they've given us a diameter in bold. So pi r squared, pi times, and it's 1.2, careful with the units as well here, millimeters squared, that's the area, multiplied by 450 times 10 to the 6, because it's megapascals. And again, even though this is a show that is roughly, we do need to come up with an exact answer for this to get our marks. So just be careful of that. So what am I doing? 1.2 times 10 to the minus 3. No, I've mucked it up. My calculator's not behaving itself. Sorry, 1.2 times 10 to the minus 3. Times 450 times 10 to the 6 gives me 509. Done. Calculate the greatest rotation frequency, number of revolutions per second. That's an interesting quantity. That is not angular frequency. Be careful. Angular frequency is, of course, a number of radians per second. So this is total rotations per second. So that is going to be omega over 2 pi. At which the sphere can be whirled before the rod breaks. So if we set the centripetal force is mass times centripetal acceleration. So it's m omega squared r. If we put that equal to 509 and then solve for omega, that implies that omega, the number of radians per second, is equal to square root of 509 divided by, what's the mass here, 0.2, multiplied by the radius 0.25. Okay, let's see what that comes out as. 100.9, and that is in radians per second, and we wish to turn that into whole revolutions per second. So there's 2 pi radians in a revolution, so we just divide that by 2 pi, to get an actual frequency. And 16 is the answer per second, or hertz. Okay. State an assumption that you have made or a factor that you have ignored in your calculation for part BII. Yeah, maybe the width of the, because there will be additional stress. There will be additional stress on that rod because it's supporting the width horizontally. So that's the only thing that I can think of here. Yeah, we have an assumption we have made. We have ignored width of ball, which adds additional. That's the only thing I can think of, unless I'm missing something obvious. So bearing in mind this previous answer, will the greatest rotation frequency before the rod breaks be larger or smaller? It will be smaller. And I think I've already answered that. I think possibly this which adds additional stress with increases stress in rod. Even if stationary, the rod is under some stress. And that's it.